Uh, okay, now interestingly enough, we can use a confidence interval to sort of look at the same question and then compare what the confidence interval tells us. Okay, so we're going to look at creating a confidence interval from this. So let's go to stats and let's arrow over to test. And I want to look for a z interval because we're doing a z interval. Okay. So go down to number 7 and I'm going to input the stats on this. Now let me just kind of clarify something here. Now if we're doing a confidence interval, our confidence interval is based on our statistic, our sample. So we wouldn't know the 0.2, we wouldn't know the 0.2 times the 0.8 divided by 400 because those are based on the population parameter. We're trying to estimate that. We're trying to see if we could figure out that it's 0.2 or not based on the 0.225. So for our z interval, the standard deviation is going to be the square root of, and this is just 0.225 times 1 minus 0.225. Okay, now I know you're thinking, what about the sample size? Well, this particular calculator will take that into account, and so I don't have to do this, divide that by 400. It will already do that for us. And so close out the square root. Then I want to type in the x bar, or in this case the sample of being 0.225. I know I had that in there. 400 being the sample size, so type that in. And let's talk about a confidence level for just a second. If I am looking at a one-tailed test that is 5%, so 0.05 being alpha, what confidence level would match an alpha of 0.05? Okay, so if I'm looking at one tail being 0.05, a confidence level is the middle percent. Okay, so if 5% is on one tail and I'm looking at what percent's in the middle, well, that means 5% has to be on the other tail. And so a 90% confidence interval should match, should give us the same conclusion as our hypothesis test. So our confidence level is going to be 0.9. Okay, so then from here we hit calculate, and it gives us 0.19 to 0.259 based on that sample size. Okay, and so let's kind of remind ourselves or just talk about what that means. If I'm looking at those numbers for a confidence interval, I'm trying to detect whether or not the actual more than 20% of the population has heard this ad. And the confidence level says, well, the amount of people that have heard this ad is somewhere between 0.19 and 0.25. So, and again, the thing about confidence levels is they don't tell me 100% of directionality. They don't tell me it's greater than a particular value. I just care of whether or not the 0.2 is in that interval or not. And because 0.2 is inside the confidence interval, it's possible that it's actually less than 0.19. If I go out and sample again, I might find that a lot less than 20% have heard the radio ad. So again, it's that radio ad that 90 out of 400 have heard. 90 out of 400 is greater than 20%, but it's not great enough. There needed to have been more people that have said they'd heard the ad, because due to random chance, if I go out and sample again, I might actually get a smaller interval. And I think in this case the radio station would probably suggest that they do that. But the point being, in the hypothesis test, the p-value is greater than alpha, so we fail to reject the null. The confidence interval, zero point 0.2, is within the confidence interval itself. So in the same sense that we fail to reject the null because of the p-value, if the confidence interval also contains that hypothesized proportion, then that would be evidence saying that it's not different. That 0.2 is good enough to assume is going on, even though that 90 out of 400 is actually bigger. It's kind of one of the frustrating parts of statistics. 90 is actually bigger than 20%, but it's not big enough So the company loses their contract, and they don't make money off of that. So anyways, I'm sure we will talk in class more about this, but there you go.